Over here, this is known as your XZ plane. Again, this is your out of plane. Okay. So we are going to analyze 3 different conditions. Okay. By the way, next week then we play with chalk. Okay, I promise you all the chalk. Next week then you'll play the chalk, and I'll give you all the opportunity. Once you break the chalk, you can throw the chalk at me. Are we clear? Okay, we do it next week. This week you're miserable. I look at you like you're going to die. So condition number 1 is where you have stress X is greater than stress Y, and shear normal stress in Z is equal to 0, and stress X and stress Y are all positive. Okay. Then later on, we are going to go into condition number 2. Okay. So in condition number 2, we have stress X is positive, stress Y is negative, and stress Z is equal to 0. Okay. That is our condition number 2. Condition number 3. All right. Condition number 3 is where stress X is greater than stress Y is greater than stress Z, and all are positive. Okay. So I want to look at the first condition first. Okay. We are going to look at condition number 1. Okay. And everything that I draw from here is going to be based on this transformation over here. Okay, it's going to be based on this transformation over here. Okay, so for condition number 1, right? So again, same thing. You draw your normal stress axis, and then you draw your shear stress axis. Okay, element, normal stress, shear stress, element rotate clockwise, element rotate anti-clockwise. So condition number 1 states that stress X is greater than stress Y and are positive. And also given stress Z is equal to 0. Okay. So we are going to sketch that now. Okay, we are going to sketch that now. So we are going to sketch where we have this is your stress X. And then you have another line. This is your stress. Maybe I'll give it a bit of space. Y and stress Z. So this is your stress X, stress Y, and you have a stress Z line. Okay. Like before, we label this surface as your X, label this surface as your Y, and label this surface as your what? Z. So we're going to put in Mohr circle. Okay. So we put here, this is your point X, because the shear is equal to what? 0. Yes? This is equal to point Y, and this is equal to point Z. Okay. So we draw the first circle. That is your first circle. So because your first circle touches point X and point Y, over here, this is for your XY plane, which is your in plane. Okay. Now, when we draw 2D Mohr circle, we only draw the what? The XY plane. Yes or no? Right? When we draw 2D Mohr circle, we draw our XY plane. Okay. Then the next circle that I'm going to sketch now, the next circle will touch point Y and point Z. This belongs to your YZ plane. And this is your out of what? Out of plane. Then finally, we have another circle. This circle, it touches your point X and Z. So this is your XZ plane, which is your out of plane. Okay. So what you see now, we are going to label this is your shear, okay, XY max. Okay. And then over here, this will be your shear YZ max. And then finally, this is going to be your shear XZ max. And we know for this case, this is our in plane. This is our out of plane. And this is our out of plane. Okay. I'm going to highlight to you now why 3D Mohr circle is important. Okay. I want to highlight to you now. You will tell me, Eugene, why we have to go 3D. 2D is enough. Okay, we have to be careful. Right. Some people say an undergrad degree is enough. You don't need to do masters. You have to be careful. If we were to draw this in 2D, which circle will we be drawing? Anyone? What color? The blue one. Yes or no? This is the circle that we will be drawing. Yes or no? And then you will say, Eugene, I don't need to consider the other surface. The stress is zero. Not important. It's not important. It's zero. Not important. Can you see shear XY max in plane? Is it the highest value? Stress Z is equal to what? 0. Then we sketch another circle. Once we do 3D Mohr circle, we realize that what? There is a bigger circle. Means, no doubt, stress Z is equal to 0, like what you see over there. It's going to generate a higher. You can only get this with what? I was an expert witness for KPMG. Sport, make a mistake, an engineer hired by the Canadian government only did 2D Mohr circle, knowing that stress Z is equal to what? Structure failed. I think, can I say more? Because I signed okay, because why? And the reason why, ignore stress Z. Reason why, ignore stress Z. And when you sketch this out, you realize that the shear, even with stress Z is equal to 0, your shear stress is higher. So now what you see, the maximum shear stress occur at where? Out of plane. No more what? In plane. You see that now? Now your maximum shear stress occur where? Occur at your out of plane. Okay. So that is the reason why we're doing the real stuff. Okay, not Mickey Mouse crap that's going around. Okay, and you have to know, 0 does not mean it is what? Safe. Are we clear? 0 in your bank account means you're duda. We clear? Okay. So now from here, we know, I'm going to write this out. If we were to look at the formula now, so we are aware that the shear XZ, okay, will be at your maximum, right? So when this is the case, we know that stress X plus by stress Z divide by what? 2. Okay. Note, in this situation, stress Z is equal to 0. So therefore, your maximum XZ max is equal to stress X divided by 2. Okay. Or we also can call it stress max divided by what? Divided by 2. Okay. Stress max divided by 2. Okay. So the maximum shear stress for here, we know that it's going to be at what? Out of plane. Okay. It's no more your what? In plane. Okay. So this is important to note. Okay. Now, all this that I've written down is only true when we are dealing with condition number 1. Okay. I repeat again, it is only true when we are dealing with condition number 1, where stress X is greater than stress Y, and both are positive when stress Z is equal to what? It's equal to 0. Okay. Now I'm going to introduce you to another situation. Okay. So the next situation that we are going to look at is we are going to look at condition number 2. And condition number 2 specify where stress X is positive, stress Y is negative, and stress Z is equal to 0. Okay. So now I'm going to bring the element across again. Okay, I'm going to bring the element across again. And now we are going to construct Mohr circle again. Okay. for condition number 2. So condition number 2 is slightly different now.